Hello, I Shivam Setia
and I Rohan
of EC branch of NSIT are here for the ATMEL-NSIT Oscilloscope Challenge 2012.
As a part of the competition sponsored by the ATMEL held at the CDC NSIT, we are presenting a game Pong to be played on the oscilloscope. Games have been long time around the corner, but they were not exactly as they look on today's gizmos. They were firstly created on electronics testing equipment like oscilloscope. This project gives us a rough idea of how some of the early games like tennis for two and the Pong actually look like.
In this project, we have created the old conventional Pong on oscilloscope, giving it the old retro look. To make the game more interesting, several extra features like high score, intro screen with menu option have also been incorporated. We would like to thank Professor Gadre for giving us an opportunity to participate in this challenge.
We would also like to thank Rohit Dureja, Shanjit Singh Jajman and Niran Stan for guiding us throughout the project. Now Shivam Setia would be explaining more about the hardware of the project.
This is the hardware that we have used for making our Pong game. Our hardware comprises of two parts. First, the DAC module and the other switch panel control. We have constructed two versions of switch module. One, the conventional wired, and the other, the wireless module. First is the DAC module that has been fabricated on the proto shield, specially designed for Arduino Uno, on which these 8-bit DAC have been mounted. The 8 bits of the first DAC are connected to the 8 digital pins of the Arduino Uno, which upon being actuated by an analog value, switch on and off the various digital pin as per the value. Similarly, this is the second DAC, which has been connected to 4 digital pins and 4 analog pins that have been used as digital pin in the program, which also perform the same function as DAC1. 10 male headers, as can be seen, have been added on the shield. These two giving the ground for the probe connection, and this is the output of the first DAC that is given on the X channel of the oscilloscope. Similarly, this is the output of the second DAC that is given on the Y channel of the oscilloscope. These four are the VCC and the ground connection of the switch. These two are the headers connected to the Arduino, to the analog pin of the Arduino, which have been set as the input for the switch module. The second module is that of the switch which have been connected to the 2 analog pins. The 2 pair of the buttons are independent of each other, as in if first is pressed, the second pair can respond to the situation, because they have been connected to the 2 different analog pins. The internal circuitry of the switch is simple analog pin connected to 2 switches in the ladder fashion, such that upon pressing of either of the switch button, a significant decrease in voltage is produced. This is the version 2 of the switch module, which is of the wireless type. The circuit of the switch remains the same, but this includes an additional ST12D and ST12E RF transmitter receiver and transmitter connected in the fashion shown in the manner. ST12E is basically an encoder IC that is connected to the transmitter of the module. It combines our 8 digital passkey along with 4-bit data and encodes it into a code that is received on the other end of a wirelessly connected board by a RF receiver connected to ST12D of a decoder IC that decodes the data and the passkey. This is the DIP switch that is used to pass the passkey to encoder and then again used to receive the passkey on the decoder side, so that the data is sent in and receive other end without any noise or interference. This is the schematics of the complete hardware. Now Rohan would be explaining the functioning of the game on the oscilloscope.
This is the introductory screen of our game, which displays the name of the game Pong. Now comes the menu option, wherein we can choose either the play option or the high score mode by pressing the up button, which is in control of either of the players. Here I have chosen to display the high score mode. Now the second time I have chosen to play the game. This is the conventional Pong game wherein the two players have their own control to move their bar up or down. Now the player 1 misses the ball and hence it displays the screen showing 1-0. Our game comprises of 3 sets wherein the game finishes when either of the player misses the 3 balls. Current score is continuously being displayed on the screen while the game is moving on, and additionally after each set a score is displayed for a while to give an indication of the current game as well as to relax the player before the next set is going to start. As is evident from the scenario of the current game, the player 1, the left player, and player 2, the right player, are playing very well, and suddenly the player 2 misses the ball and screen for 1-1 being is displayed. Oh, there's a fumble from the player 1 side and the score goes to 2-1. In our game, the player which leaves the ball gains a point and other player gets to get the ball on his side in the next set. The aim of the game is to keep your score as low as possible while keeping the ball to reflect from your bar. And here comes the final screen showing the victory for player 2. Hope you enjoyed playing the game or must have at least lured at it while watching the video.
There are further improvisations that we wanted to have in our game but we couldn't complete because of the time constraint. These include gesture recognition input for the Pong oscilloscope wherein a user can input from a gesture recognition so that the bar moves upon his hand gesture. Given upon the time, we could also improvise upon this technology and come up with a better solution and a better Pong on oscilloscope.